In this third video for derivatives, we're going to look at what's called the power rule. We're only going to apply it to polynomials for now. When you take calculus, you'll learn about the power rule and how it applies to different types of functions. But we'll stick to polynomials only. So far we have found the derivative by using the definition. Some people call it the long way. We had to find f prime of x, the derivative of x, was the limit as h approaches 0 of f of x plus h minus f of x all over h. But if we use the power rule for derivatives, then we're going to follow this rule instead. So what we do is for a given function, so let's say our function is a times x to the n power, and a polynomial will have that and many terms that will look like that. So what we'll do is we will take the exponent, so this n, this exponent, and we will multiply it by the coefficient, and then we will take what that exponent was and we will subtract 1 from it, so it will be 1 less than it was. So if you can see here, that's what the rule is. So let me show you what it would look like. So I have an example here that's just a monomial, but it's still a polynomial. So to find the derivative of f, or f prime of x, we're going to take the exponent and multiply it by the coefficient. So 7 times the 4, and we keep our x, but now we take our exponent and we subtract 1. So it was 7, so now it's 6. And so the derivative of our polynomial, or a monomial in this case, is 28x to the 6th. Now you don't have to show all that work. You can do that multiplication and that subtraction in your head to get your answer. I just wanted to show you what it was that I was doing. Alright, so let's do this last example. So again, we have a polynomial here. It has 4 terms. So when we find the derivative of x, or g prime of x, for each term we're going to take the exponent and multiply by the coefficient and then subtract 1 from it. So we multiply. So 18x to the 2nd now. The next term, positive 10x to the 1st now, and I don't really need to write 1, but you can. Alright, for the next one, our exponent was 1, even though it's not written there, so we multiply it by the coefficient, so negative 9, and then when we take 1 and subtract 1 from it, or decrease it by 1, it becomes x to the 0. And our last one doesn't have an x, but it's x to the 0, so when I multiply that, I get 0. So I could put plus 0 or not, but that's not really how I'd leave it. So 18x squared plus 10x are all simplified. Minus 9 is really, it's just minus 9. You don't write x to the 0 because that x to the 0 is just 1. So negative 9 times 1 is negative 9. And I don't need to put the plus 0. So the derivative of that 4-termed polynomial is now 18x squared plus 10x minus 9. And when you're trying to find the derivative at a specific value, so for example, if I said for this problem, don't just find the derivative of the whole function, maybe find the derivative at 4. So if I were to do that, then all I'd have to do is plug in 4 into the derivative, and then I could get my answer that way. And if I plug that in, I will get 319 would be my derivative at 4.